Okay, so this is the last video for section 1.2, where we're going to see some real life examples of what we've been learning. So it's always very important when doing a real life example to take the time to read the problem word by word, carefully, possibly more than once, to try to understand what it's asking, because that's usually the hardest part of the problem, is just to understand what it's asking. All right, so the height of a golf ball is modeled by the equation h of t equals negative t squared plus 4t in meters, so that means the height is in meters, with t representing the time the ball is in the air measured in seconds. So the independent variable is time, and the dependent variable is height. So for part A, we're asked find the height of the golf ball 2 seconds after it was hit. Okay, so let's figure it out. So we have to find the height, so that means that we're trying to find h, which is the y value basically, and we're given that it's 2 seconds after it's hit. So t is 2. Okay, because it says that t represents the time in seconds. So what that means is now we can use the equation negative t squared plus 4t equals h to find h when t equals 2. That is, I will plug in t equals 2. Please be careful. There's no parentheses around the negative, so I am not supposed to put 1 there. So this is negative 2 squared plus 4 times 2. We're going to find it. So this is negative 4 plus 8, which is 4. And we must always use units when we can. We are given that this is meters. So the answer is 4 meters. Okay, so for part B, we are asked, after the ball is hit, how long does it take to reach the ground again? So this one isn't quite as straightforward, but we can still figure it out. So how long, that's what we need to know, and we know that the time is measured by t. So this is saying we need to find t, and then what does this mean when it's going to reach the ground and again? So it's on the ground, its height above the ground is 0. So we're going to find t when h equals 0. And we'll kind of understand what it means again, but if you think about it, like you guys know, like if you hit the golf ball, it's on the ground, it goes up, and then it comes down again, right? So basically there's going to be 2 times when h equals 0. H equals 0 at the very beginning, and then h equals 0 again at some point. So that's the one that we're going to be looking for, okay? So that's just a preview. So to set it up, we take our equation, I'm so sorry, it just disappeared. We take our equation, negative t squared plus 4t, and we're trying to find t this time when h equals 0. So there are different ways to solve this. I would prefer to solve this by factoring, so I'm going to take off a t. So I would have negative t plus 4 when I factor it. And then by the zero product rule, if the product of 2 numbers is 0, then one of them is 0. So this means either t equals 0, that's one solution, or minus t plus 4 equals 0. And on this one, I could add t to both sides, and I would have t equals 4. Okay? So basically, how do I know which answer to give? Well, t equals 0 is before I hit the ball, so the again one will be t equals 4. Okay? So we should say that t equals 4 seconds, because I said we should always use units when we can. Okay? So after 4 seconds is when it would reach the ground again. So basically, in combining like what we did in the first part, we know that after 2 seconds, this is kind of like where it was, like after 2 seconds, it's up at 4 meters, right? So it does make sense, like the whole picture kind of comes together. You should always do the little reality check when you are doing word problems. Okay, so that was very algebraic. And in problem 6, we're going to be a little bit more geometrical or graphical in terms of thinking about a real life application of functions. So for problem 6, we are asked to consider the given graph of the function c. So c is the name of the function instead of calling it f, but that still means that c is the y value, basically the dependent variable, where c represents the cost of manufacturing q computers in a day. So q is like the x, okay, which is the independent variable. So I already know that q is the number of computers, and then c is the cost. So in part A, we're asked to determine c of 0. So that means when q equals 0, what does c equal? And I can find out because I'm given here that the point 0, 5,000 is on the graph of the function. And so I can say that c of 0 equals 5,000, but I want to interpret this and maybe like put units to it. So what does that mean? So that means that 0 computers cost $5,000 to manufacture. I mean, that's like a very basic interpretation of it, right? And you might be like, what? Why does it cost $5,000 to make 0 computers? But if you think about it, no matter what, we still have to like pay some kind of fixed overhead costs, like keeping the lights on, the electricity, paying the workers just to come into work, paying for their health insurance, like all this kind of stuff, right? So that's just the base cost that we have. All right. So once we know that, then we can answer the remaining questions. So for part B, it asks us to determine C of 10 and interpret. So for C of 10, I'm going to use this point on the graph of the function to say that C of 10 equals 19,000. Meaning that when Q equals 10, C equals 19,000, which means that it costs $19,000 to manufacture 10 computers. Okay, so I'm thinking probably at least some of you are business majors, and so this will be very relevant to some of your later studies, so hopefully you enjoy the example. Okay, C of 50 is here. So C of 50 is 51,000. Okay, C of 50. And then I think you're seeing the pattern, so that means it costs $51,000 to manufacture 50 computers. Right, and so, I mean, it's kind of interesting if you think about it, like how many computers should I manufacture if I run this company? These are the types of management decisions that you would have to make based on this type of graphical information, yeah? Okay, and then the last question is part D, which asks us, what's the domain of C? And then again, what does this imply in terms of daily production? So we know, let me change color. We know that the domain is talking about the X values, and this one is a little different because usually our graphs just kind of keep on going forever in either direction. But if you really look at this graph, like the only X values that actually have Y values are on this X interval, right? It seems like it only goes from 0 to 100. So I would have to say that the domain of C is only from 0 to 100. So Q can't be less than 0, and Q can't be more than 100. So what does that mean? Does that make sense? I mean, remember, Q is the number of computers we make in a day. So, like, the fact that it can't be less than 0, it does make sense. How could I have a negative computer, right? And then the fact that it can't be more than 100, well, it's also, there's physical constraints on a factory. So this factory can, obviously, it can't manufacture a negative number of computers, and it can only manufacture at most 100 computers in one day. Okay, so if you actually, like in this case, it wouldn't happen because you didn't even have the equation, but if you just had the equation and then you found that there was no numbers you can't plug in, you might think, oh, the domain is all real numbers. But especially with real life situations, please be careful that sometimes, even if like theoretically you could plug a point in, maybe practically in terms of the practical application, it doesn't make sense to do so. Okay, that's the end of section 1.2. Thanks, guys.